Okay, so dear student, in this video, we derive another one expression related to electric dipole, that is torque. Okay, in previous videos, we calculate two derivation. We calculate the electric field due to the electric dipole on the axis and at the point, equatorial point. Okay, that is to application of electric dipole. Now here we derive the expression for torque. Torque means torque means force. When a force applied on two charges with which the electric dipole is consist, that is called torque. Okay, so let's start. This is a diagram for this one. This arrow sign, this is a uniform electric field. So torque acting on an electric dipole in uniform electric field. Electric field must be uniform. Uniform means parallel to each other. Now here we placed one dipole with an angle theta with the electric field. Clear? AB is a dipole, A minus Q at B plus Q, and distance between them is 2A. Now, when a dipole placed in uniform electric field, a force is exerted on each charge, on minus Q at point A and plus Q at point B. So the force on minus Q charge in opposite to the electric field, this direction, that is minus QE, because we know E equals to F by Q. So F equals to E into Q. Okay, because negative charge is here, that's why minus QE. Positive charge is here, so that's why plus QE. Now these two forces are equal but in a opposite direction. Clear? These two forces are equal but in a opposite direction. So net force acting on a electric dipole is 0. Plus Q minus QE plus QE equals to 0. Sometimes this portion will come as a 1 marks question or 2 marks question that proves that the net force acting on an electric field when it placed in an uniform electric field is 0. Clear? So net force acting on an electric dipole when it placed in an uniform electric field, that is 0. Now we derive the torque. These two forces are equal, parallel, but in the opposite direction. So when two forces are equal in magnitude but in the opposite direction, they produce a torque on it. It tries to move the electric dipole in this side, it tries to move in this side, but because this two amount is same, force amount is same, that's why electric dipole on electric dipole a torque is exerted. So torque means either any one force, because both magnitude is same. So either any force and the perpendicular distance between two forces. Perpendicular distance, this one, perpendicular distance between two forces. So either force, that means we consider here the magnitude, that's why we did not write minus and plus. So magnitude is Q into E and the perpendicular distance is AC. AC, we calculate AC. So from figures we know that sin theta equals to AC by AB. If this is the theta, this angle also be theta. So sin theta equals to AC by AB. AC equals to AB sin theta, and AB is the length of the electric dipole, that is 2A sin theta. So in place of AC we write 2A sin theta. Now we know that 2A into Q, that is called dipole moment. So here we write dipole moment P, another one E sin theta. So torque is represented by this sign, small t. Okay, but not like this way, you write this one. So we get tau equals to PE sin theta. This tau represents torque. So torque means any one force, that means the magnitude of any one force into perpendicular distance between two forces. So torque equals to PE sin theta. Now if we write in a vector form, and we know that when we study in class 11, sin theta exists between two vectors. When the two processes are there, one is a dot product, another one is a cross product. When we use the cross product, when the when the product of two vectors also be a vector, that time we use the cross product. Because torque is a force and force is a vector quantity, so torque equals to P cross E. So sin theta means cross. So tau equals to P cross E. So P into E, dipole moment into electric field, P cross E. Clear? So in diagram, in vector diagram, we can write this way, because P cross E means P to E. This side movement, so it's moved like this way. Okay. So SI unit of tau is Newton into meter. Because force into perpendicular distance, so force is Newton, perpendicular distance is measured by meter. So SI unit is Newton into meter. So this is the expression for torque acting on an electric dipole. Now here some special cases also be there. Two special cases are there. We have this equation one, tau equals to P cross E. Another one, P is sin theta. Okay, first equation, when it will be maximum value, when it will be have minimum value, when torque is maximum, when torque is minimum. If the angle between electric field and electric dipole is 90 degree, that means electric dipole and electric field are perpendicular to each other, then sin theta equals to 1, because sin 90 value 1, sin 90 value 1, then tau equals to P. This is a maximum value. So when it will be maximum, when the angle between electric field and the electric dipole is 90 degree, or they are both are perpendicular to each other. Now when it has a minimum value, when theta equals to either 0 degree or 180 degree. 0 degree means parallel to the electric field, 180 means anti-parallel, mean if this side is the electric field, electric dipole moment is this side, direction is this side. Okay, so either it will be parallel to the electric field or in anti-parallel to the electric field. Theta value 0 or 180 degree, sin theta equals to 0, because we know sin 0 equals to 0, sin 180 also 0. That means no torque is acting on a dipole, because when they are parallel or anti-parallel to the electric field, no force exerted on it. So tau equals to we get 0, because P is sin theta. If sin theta value is 0, then tau equals to 0. So it has a maximum value. This is a condition for electric dipole is in a equilibrium. This is a equilibrium condition, when the electric dipole or is in equilibrium condition, when no torque is applied on it. Because if the torque is applied, one force try to move in this side, one force try to move in that side, there is a, but this is not an equilibrium. Because force, we know that when we apply any force, this is not the equilibrium. When no force apply on any object, that means object is in an equilibrium position. So this second one, when theta equals to 0 degree or 180 degree, then tau equals to 0. That means no force acting on a, no torque is acting on a dipole. And this condition, and in this condition, electric dipole is in a equilibrium. Clear? Thank you.